Okay. Hey, hello everyone. Thank you so much for joining us today. We're so excited to present this webinar, Exploring Ocean Mysteries from Dynamic Shores to Deep Oceans. These resources were funded through an award through the National Geographic Society to the National Marine Sanctuary Foundation. However, we could not have done this without Rick and Krista from engaging every student. They have carried so much of this to get this live and active. So thank you guys so much for getting us here. Just some quick things as we start this presentation. If you go to the next slide. So this meeting will be recorded. I will be monitoring the Q&A section, if you can see that. If you aren't able to see the Q&A section, it might be because you're in Safari. We're hearing that there might be some issues with there. If that's true, please try to use another browser like Chrome or Firefox. So hopefully you can get the full experience of this webinar. We will be posting links for people to click through during this presentation. So feel free to, save those links as we go. If you have questions, I also please use the Q&A section to put your questions in. We will keep all attendees muted and cameras will be off throughout this whole presentation. So please just keep that in mind. So if you raise your hand, we won't be answering it. So any pressing questions, please put in the Q&A. If you need PD credits, send me an email and I will send you a certificate of completion for 1.5 hours. Next slide, please. So I just want to give a little background about the foundation. The foundation this work is being done through the foundation, the National Marine Sanctuary Foundation, which was founded in 2000. We're a leading voice for U.S. protected waters, and we work with communities to protect these areas across the United States, its territories, and beyond. We work in community outreach, conservation, education, science, and tech. If you want to learn more about the foundation and everything we do, I will be dropping our website and our listserv link in the Q&A section. Feel free to join our listserv. We'll be sending out emails about similar events like this webinar, our Capitol Hill Ocean Week here in Washington, D.C., our speaker series, Blue Beacon, and other future grant opportunities for our projects. And next, I would like to introduce the Foundation's close partner, NOAA, and more specifically, Tracy Haidu, the National Education Coordinator, because without her, this project will never become buoyant. So thank you, Tracy.
Thank you, Deanna.
Keeping us afloat.
Thank you with the good puns. We'll be having many of those as we go. So welcome, everyone. We're excited to have you. Again, my name is Tracy Haidu. I am the National Education Coordinator for NOAA's Office of National Marine Sanctuaries. So you can see from this slide, there's actually several of us who are going to be talking tonight. The majority will be Rick and Krista Reynolds, who will be going through the bulk of the presentation, but I am on as well as one of our educators from our National Marine, our Sanctuary in American Samoa, Belle, and again, Deanna is our host tonight. So you'll have a full team of us helping out as we go through the evening. Next slide, please. So I'm going to quickly go through the agenda. I'm going to start off with a brief background on National Marine Sanctuaries and Monuments and what they are. And then I'm going to talk a little bit about the ocean literacy principles, if you're not familiar with those. Next, we're going to turn it over to Rick and Krista to get into the meat of the program, including starting with the land and water acknowledgement. And then we're going to go through the 17 new amazing resources we have that have come together to create the Exploring Ocean Mysteries lessons. And through that, we'll also be talking about the connections to next generation science standards and Common Core standards. Sorry, my cat keeps on visiting me as we go. She hears me talking and thinks I can come say hi. And we will be, again, keeping the evening light with some interactive activities and silly ocean humor to make sure that we're all awake and just having fun with this topic, because we clearly all have an interest in helping kids learn more about the ocean. So this is a map of the National Marine Sanctuary System. This is managed by NOAA. So this is federally managed waters and Great Lakes. And we manage 15 national marine sanctuaries and 2 marine national monuments. We serve as the trustee for a network of underwater parks encompassing more than 620,000 square miles of marine and Great Lakes water. And one of the reasons that this project, again, was funded by National Geographic and the National Marine Sanctuary Foundation, but they wanted to have a location of these lessons. And so we chose the sanctuaries to kind of give them a place rather than just kind of talking about the ocean in general. This helped kind of hone in on certain places within the United States, because these really are the best of America's underwater parks. And it could be shipwrecks, cultural resources, historical connections, ecologically important areas, or for species, and so on. So there's a lot of different reasons that a sanctuary may be designated as we are in the past. Next slide. So what do we do at sanctuaries? We first of all, again, as I was just talking about, there's things in these waters, right? They're important places, and one of the things is to protect whatever is there. Again, it may be a shipwreck of historical importance that actually may still have sailors' remains on it, even from hundreds of years ago. There's ecologically important areas. There's coral reefs and kelp forest and birthing areas of humpback whales. So we are, one, managing and protecting these places. Two, both our scientists and in collaboration with universities and other researchers are studying these ocean places, these ocean and great places, to learn more about them. Another thing is we are required to do education and outreach. And so we really want to make sure that we're sharing all of this information with all of the American publics, teachers, students, lifelong learners, anybody who is interested. And as we all know, the ocean really does connect us all. So that is a big component of what we do. And we do that through our community engagement. We obviously are located in places around the country, but we really want to share these sanctuaries with the whole USA to make sure that everyone knows about them and the resources that are there. Next slide. So I'm just going to talk a bit about what we do for education. If you're lucky enough to live near a sanctuary, we do offer field trips, and we have visitor centers that you can visit. We have virtual reality videos. So if you are not able to get to a sanctuary, this allows anybody, no matter where they are, to be able to access these sanctuaries and see what it's like under the waters, and really experience the things up close, it's a really amazing series. It is worthwhile to check out. We have lesson plans and activities similar to what we're going to be talking about tonight. We also give out grants to schools and nonprofit organizations for environmental education, getting kids outdoors and into their watershed. We have a webinar series where we are have researchers and other people talking to anybody in the public, interested educators, informal educators, the general public, about what's happening in sanctuaries. And then we have a lot of free resources. We have ocean photos, we have videos, and other things that are all free. All of our materials are free. Our visitor centers are free because, again, we are the federal government, and a lot of student opportunities. So you can find out more specifically at the website, which is listed below, sanctuaries.noaa.gov/education. And we also do have a listserv as well if you're interested in keeping up to date on what's happening. Deanna can put that into the chat. You can also join our listserv to find out more information about the sanctuaries in the future. So I want to touch a little bit about on ocean literacy. So if you're not familiar with ocean literacy, or maybe you heard of it, but it's been a while since you've kind of heard the definition. Ocean literacy basically means an understanding of the ocean's influence on you and your influence on the ocean. And the idea is that everybody should be ocean literate. Everybody should understand their connection to the ocean, the ocean's connection to them, no matter where you live. Specifically, an ocean literate person understands the essential principles and fundamental concepts, which I will explain in just a second. They can communicate about the ocean, and they're able to make informed or responsible decisions, because even if someone's not going to be an ocean scientist in the future, we want everyone to be aware of how their daily lives and the choices that they're making are impacting our ocean. So the essential principles, actually, if you can go back for 1 second to the slide, are actually these 7 things on the side of the slide. And so what these principles have been around for about 20 years now. And these are like major concepts of, again, what everybody should know about the ocean. And under these 7 essential principles, there's what's called fundamental concepts, which are even more broken down information about them. And as we made this series, we use these 7 essential principles as the guiding feature. So we're going to be referring back to these 7 principles quite often throughout the time tonight. Can you go to the next slide? So something new for ocean literacy is, again, we have the guide, which is kind of what we were talking to, those essential principles and fundamental concepts. Recently, they've also made the scope and sequence for grades K through 12, and this really breaks down how these principles relate to classroom learning and standards in those grades. And you can look it up by grade level and really get into detail. And it's this whole conceptual flow map that is really detailed, but has a lot of great information if you're looking to teach ocean literacy in your classroom. And there's also been alignment of the ocean literacy ocean literacy principles to NGSS to make it more clear of how these connect to the standards that you may be teaching in your state, depending on where you're located. All of this can be found in the handbook for increasing ocean literacy. And all of this information is on the website, which is oceanliteracynmea.org, which is the National Marine Educators Association, and they're the ones that host all of the ocean literacy information. So if you want to learn more, please check out that site. So with that, I'm going to turn it over to Rick and Krista to get us started on our land and waters acknowledgement.
All right. Hi, everyone. Wonderful to be with you. Great to see everyone adding their info in chat. Great to see where you're coming in from. We wanted to start by acknowledging the land and waters that we benefit from here in Oregon. And we use the National Geographic Mapmaker program. It was just updated recently, and it's very kid-friendly. You can find it if you are interested at mapmaker.nationalgeographic.org. Maybe wait to do it later because we're going to be cruising through a lot tonight. But when you get there, you can just click add a layer, and then you can add the Indigenous territories layer to show this. And I just zoomed in on Oregon so we can have that as a visual to say, greetings from the traditional lands of the Tualatin Kalapuya or Atfalati people, past and present. We gratefully honor the lands and their stewardship of them since time immemorial. This calls us to be better stewards of our land and waters so that future generations can share in their beauty and abundance. And before we really dive into the full meat of the curriculum, it is focused on exploring ocean mysteries. What do you think of when you hear that term, ocean mysteries? So you can go to the URL there. Deanna's going to add it in the Q&A section, or you can just type that URL there, the tiny URL. You can also use this QR code. If you point your QR code at this with your phone, use your camera app, and it'll pop up with a little link, and you can click on that little text link that shows up, and it'll load right on your phone too. So either way, that'll bring it up. It might even work if you go to slido.com. That's what this little tool is here, and entering in that code. All right, so sea creatures, exploration, deepest parts of the ocean, the deep sea. Yes, so much left undiscovered there. Biodiversity. Great, that's a great start to it. I'll give it just maybe 30 seconds more since we have so much to cover, but we can come back and check on these later. Mythos, very cool. Researcher, especially with the Indigenous peoples. Unexplored, look at that. A lot of people put in unexplored. Elusive, great stuff. So thank you, everyone. I'm going to keep moving, but we'll check back in later. If you think of other things, feel free to keep adding. So the curriculum is aligned to the 3 dimensions of NGSS. And when we talk about 3 dimensions, if you're not as familiar, this is one of the tables that's in each lesson in the curriculum, has one of these tables towards the end of the lesson, and it will lay out the disciplinary core ideas. That's one of the dimensions. That's the content, things like ecosystems or ocean concepts. And then we've also got the science and engineering concepts. These are, or science and engineering practices. These are things like developing and using models. You'll hear us talking about those a lot tonight, constructing explanations and designing solutions. And we also have our cross-cutting concepts. These are things like energy and matter, structure and function, systems and system models. So all of the lessons are aligned to the 3Ds of NGSS, as well as the Common Core State Standards. Anytime we're talking about giving the students opportunities to practice writing and reading and presenting claims and findings, sequencing ideas, these are all ways to meet Common Core that you can integrate throughout learning about the ocean. And then each of the lessons will show you which ocean literacy principles we're aligning to specifically, as well as climate literacy principles are woven throughout. So here's kind of a quick overview of the curriculum. You can see that for each one of the ocean literacy principles, we have at least 2 lesson plans to use targeted to grades 6 through 8, but adaptable for grades 4 to 12. We have many different enrich extend activities, so you can easily do this with high school as well as younger students. And we're going to dive right into the first ocean literacy principle here, which is Earth has one big ocean with many features. When we went through school, if you're anywhere near our age, we learned about the Pacific Ocean, the Atlantic Ocean. We now know that they're all connected into one circulating system. And so we want the students to understand that. We have one ocean. And the first lesson to bring out this idea and help students explore it is mapping friendly floaties. In case you're not familiar, these friendly floaties were kind of famous in 1992. There was a ship that was traveling across the ocean that dumped 29,000 little rubber duckies, little froggies, and other plastic toys into the ocean. And we're still finding them today. And so that's the phenomenon. Each one of these lesson plans highlights a phenomenon. They all start with an engage activity. So all of these are in the 5E model. If you're not familiar, the first E is engage. I've been a teacher 30 years, and I know that, you know, if you don't grab those kids right at the beginning, the rest isn't going to matter. So we start with engage, and then we give the students a chance to explore the concept where we haven't told them too much about it yet. They're just kind of playing around, exploring it. And then the 30 is explained. So after the kids have played a bit, they can come back, they can tell you what they're discovering. You can fill in details. So the explaining happens both ways, from the students and from the instructor. And then the 4th E is enrich extend. So you'll see that at the end of all the lessons, different ways to engage a variety of different learners. And then the last E, evaluate. So we need to know what the students are learning and help improve these lessons over time and be able to give the students a chance to share what they've learned. So now back to the story. So the rubber duckies have been dumped into the ocean by this ship. There was a big storm. And so now you've got these 29,000 rubber duckies floating around the North Pacific. And so we tell the students this, we show them the spot on the map. This is all a PowerPoint presentation. You'll have these presentations to use with the lessons. And from this location, we ask the students to imagine you're a rubber ducky in the North Pacific. Where would you go? And all of your 29,000 friends. So we give them a chance to predict that. They can use their science notebooks or a map. We have paper maps you could pass out. There's also a tech tool that you can use that's here. It's ArcGIS Online, and we provide the link to go directly to this marine debris, environmental science, geoinquiries map, and this is interactive. The students can turn on and off these different layers, like the red arrows here showing warm ocean currents, the blue arrows showing cold currents, and from this make a prediction where might they have traveled starting from that location in the North Pacific. They can also turn on other layers such as prevailing winds, and these are tools that you'll see over on the left-hand side when you try this out. There's also this presentation, as I mentioned, and this is another slide where we ask students to think about what these arrows are showing and how it might have impacted the floaties. And these are winds like the westerlies and trade winds. So another part of the exploring process is this handout that you can pass out to students. We suggest that they work with a partner or a small group and try to find these locations on the map using latitude and longitude. And they can see from that Floaties Overboard event in 1992 where they might have popped up. So these can be marked on the paper map or on the ArcGIS Online map. And then they can start putting this together, how the ocean currents and prevailing winds could have sent these floaties traveling near and far. And so on this sheet, they can see to add the dark blue arrows, red arrows, and black arrows to represent those things. I just started adding them here. This is the paper map that you can pass out showing some of these, and then the students can start adding little rubber duckies to indicate these places, or stars, or however they want to show these locations on the map. And then they can try to come up with an explanation for why they showed up in those places based on the currents, and then they can start adding winds here to explain that. So then they come back together as a class, show their maps, talk about them. You can share them with the data projector if you have one. And then we ask them to go a step further and ask, which national marine sanctuaries might the toys have visited? So following the currents again, they can make those predictions and the winds. And then we say even tiny particles of them too. They might know that these plastic things, if they're in the ocean long enough, they'll break down and become tiny. So the students should realize that they could basically go everywhere. And we wanted to point out that everything is in Spanish. So muchas gracias to Victoria Martinez Adelaide, who is an incredible translator. If you ever need anything translated, she turned all of these resources into Spanish, and they'll be on NOAA's site soon. You can also email me, rick@engagingeverystudent.com, if you need those sooner. We can even share editable versions of all of these handouts and rubrics and lesson plans if that would help you. So again, this ocean principle number 1, the Earth is one big ocean, or has one big ocean with many features, and water travels around it via ocean currents and winds. The next lesson continues from that first lesson into exploring marine sanctuaries more in depth. And so with this one, we have a series of cards. You can print these out, cut them in half, and then have the students play a game in the explore phase. They can just match up these cards using the descriptions of them and the names, like Papahana, Makuakea, Marine National Monument here, and the photos. And then they can come back together and share which ones match up. Then they can choose a sanctuary or monument that they'd like to focus on, working with a partner. We suggest, because we are such social creatures, and then the students can either present about their sanctuaries. We have this handout to kind of guide them through the research process, or you might give them a choice of the medium that they would like to be able to share it with. Maybe they would like to create a video or do a diorama about their sanctuary. Sometimes giving them options is a lot of fun. Okay, so speaking of fun, let's take a quick humor break here with this one. See who can figure this out. How did the ocean greet the National Marine Sanctuary? Think about the language of the ocean. It just waved. And photo credit to Krista's awesome dad, Brent, who just took this at the Oregon coast, just massive waves at the ocean right now. And we got this from Victoria, who joined last night, our translator for the Spanish speakers out there. Como saluda el mar? Joke in Spanish for you. Hola. We just learned that hola in Spanish also means wave, and hola is also hi. So thank you, Victoria. Wonderful. And
Spelled a little differently.
Spelled a little differently. She came up with that at 2 a.m. because she's actually in Germany right now. All right, so this last lesson in Principle 1 tries to bring in the students' personal experience even more. And so we introduced the concept of a watershed, and the lesson's titled Watersheds to Whales. If you're not familiar, the watershed is every place on Earth that water lands on, every bit of land that the precipitation hits will drain back to the ocean. And so we ask students to think about their watersheds. You can model these. So one way to do that, we suggest a couple ways. One is to crumple up a piece of paper, uncrumple it, have the students draw lines across the ridge lines to show how one side is going to drain one way, one side is going to drain the other way. They can add blue, places where they think streams might form, lakes and things, and then pull out some spray bottles and start adding some precipitation to these models so the students can test their predictions where this water might have flowed. You can see here we've got a couple of watersheds. These are some small watersheds down near the Monterey Bay Sanctuary. And then we've got the huge watershed of the Mississippi River Basin. So think about for a moment how the ocean connects to your life personally. We want the students thinking about, you know, how if they have trash in their neck of the woods, that might make it back to the ocean, how they might get different benefits from the ocean. And just think about what those good things and other things might be, and you can put that in the Slido here. So there's a link. I believe Deanna is going to add that to Q&A, or you can use the tiny URL, or we have our QR code if you point your camera at it. So breathing. Very good point. Chris is going to be talking about that.
I'll be talking about that a little bit later.
Where would we be without all that oxygen?
Life.
Life. So true. Chris is also going to talk about how life evolved in the ocean. Looks like some people are typing. Happy
Food,
place,
culture. Yeah.
Life. Excellent. Yep. Our favorite place on Earth is
Weather,
the ocean.
very important.
Excellent. Well, this is great. Keep these coming. If you think of more throughout the workshop, we'll come back and check on them. But climate, we'll be talking about that as well soon.
Traditional fishing.
Important it is. Jobs, so many jobs connected to the ocean, from fisher people to scientists to videographers. Absolutely. Biodiversity. Okay, well, let's keep moving. We can come back and check on it. Recreation. Thanks, folks. All right, so now I'm going to turn it over to my lovely wife and collaborator, Krista Reynolds.
Thank you, Rick. And I'll be talking about Ocean Literacy Principle 2 and the lessons associated with this. And the principle is that the ocean and life in the ocean shape the features of Earth. And going back to our table of lessons, there are 2 lessons under this principle: exploring sanctuary landscapes and sifting sanctuary sands. Our first lesson, exploring sanctuary landscapes. For this lesson, we chose to focus on earth science and the ocean's interactions with the land. One question to engage students with is, why do coastlines on the east and west coasts look so different? Take a moment to think about how the land differs between these 2 locations and why that might be. In the lesson, we include photos of different features that students take a look at, and you can give students a more realistic and dramatic view of the landscapes by using Google Earth. So we're going to switch over to Google Earth for just a moment. And if you haven't used Google Earth before, I highly encourage it to bring these landscapes to life. We just did a search on Point Reyes in California, which is near Greater Farallones National Marine Sanctuary. And this is our 2-dimensional view, but if you click on that 3D button at the bottom of the screen, it really makes this very dramatic, and students can see exactly what this landscape looks like from overhead. We're switching back to the presentation.
We always hold our breath. Is it going to share? It's sharing. Yay.
It looks like it's sharing. Okay. But it looks a little blue. So, okay, no, we're good.
It is a little blue. Teams, you're letting us down. Anyway.
No, I think it's all right. So our objectives for this lesson are that students will describe the physical differences between different coastal landscapes. They'll hypothesize about the geologic processes that form these landscapes and how the ocean impacts them. Some key terms from this lesson are erosion, deposition, plate tectonics, and volcanic activity. And so students are given photos of different geologic features within or near the National Marine Sanctuaries, and they attempt to match descriptions of those geologic processes with those features. And the image on the right is an example of a slide from the teacher's PowerPoint, which is included with this lesson. And it explains the geologic processes affecting this coastal area, which in this case is Point Reyes again, which I mentioned is near Greater Farallones National Marine Sanctuary. And so here, the San Andreas Fault is shaping this particular landscape. To engage students, we added a bit of fun by asking them to read this short 100-year-old story about the possibility of buried treasure on a California beach. And we asked them to think about what time of year might be best to look for buried pirate treasure on the Monterey Peninsula and why. When is erosion by waves, seasonal storms, and currents most powerful? When is there seasonal deposition of sand? And so this is an example from the student activity, this slide, and we asked them to look at photos of other coastal features and think about where are you and how did this coastal landscape form? And so these are sea stacks that were formed by strong wave action, and those softer materials eroded away, leaving this hard sea stack behind. And then you can see in this photo, there's a very wide sand beach, which was formed by rivers depositing sand there, and also longshore currents that move along parallel to the coast. And then gentle summer waves rebuild these beaches after these seasonal storms in the winter. And where are you? So we are at Olympic Coast National Marine Sanctuary, way up in the upper northwest corner of Washington State. Here's another example students can look at. What forces created this landscape? And here, sands were created from calcium carbonate skeletons of coral and other organisms. And wave action from storms, including hurricanes, redistributes these sands locally. And where are we here? Any guesses? I'm going to give it away. It's Florida Keys National Marine Sanctuary. And whereas the West Coast is characterized by those really dramatic headlands and cliffs, sea arches and caves, the East Coast is relatively flat, these low elevation beaches. Here are a couple of pages from the student activity sheets, and students compare photos of the same beach taken in the spring and in winter and think about the forces that change this beach. So you can see in the photo on the left, there's been sand deposited here in the late spring. And then on the right, sand has been washed away during some strong winter storms, exposing those rocks on the beach. Then we ask students to graph beach height measurements taken at 2 different times of year to create 2 different beach profiles. And this goes back to the question, when is the best time to discover treasure buried on the beach? Based on their discoveries about the forces that affect beaches on the east and west coasts, we asked students to recommend at which sanctuary they would bury treasure to make sure that it stays hidden. And so our second lesson under Principle 2 is called Sifting Sanctuary Sands. And again, this relates to the principle, the ocean and life in the ocean shape the features of Earth. We build from the previous lesson, and the phenomenon we present students with is, not all sand is the same. And in this lesson, students will examine photos of sand samples from a variety of beaches. Take a moment to look at these two photos. How are these sands different? Where do you think these might be found? Give you a moment to think. If you thought the sand on the left looks partly volcanic, you're correct. That sample is from Hawaii Island. And the different rock and sediment sizes on the right indicate a well-eroded beach. This one is found at Olympic Coast National Marine Sanctuary in Washington. So for this particular activity, we suggest that you create a model of the Pacific Basin. And you can create 9 stations with sand photos from different beaches, and the locations of those are pictured here on the map. You can create a fun atmosphere by playing beach-themed music and encouraging students to come to class with sunglasses, hats, and other beach gear for their day at the beach. And so this is one of the slides from the teacher presentation, again, showing those locations that students will visit virtually. Key terms in this lesson are deposition, rock cycle, sediment, and weathering. And we ask students to closely observe the sand photos and think about ways of classifying sand and hypothesizing about its origins. Here's a screenshot of a portion of the student activity sheet. Students will realize that sand can be made up of biological components as well as rock. We have another humor break. And for this one, I want to acknowledge my middle school marine biology teacher, Richard Duncan, who told lots of goofy jokes in class and fostered my love of the ocean and science in general. So what did the beach say when the tide came back in?
Wasn't it long time no see?
It was, good job. Moving on, back over to Rick.
Okay, well, let's keep moving right into Ocean Literacy Principle 3. Some folks brought this up earlier, that the ocean is a major influence on weather and climate. And boy, are we realizing that this year we have a very strong El Nino year. That's where we have these warm ocean waters off the coast of South America, and that is really driving our weather. It is so warm here in Oregon, very wet. And I know other places in the country are really feeling it as well. So the lessons here are exploring El Nino and impacts of changing ocean temperature, as well as investigating albedo and ocean feedback loops. So with this lesson, the phenomena is looking at these different ocean temperatures in different years and how that impacted climate in those years. And we suggest using this tool NOAA's created. It's the NOAA View Global Data Explorer. And you can just bring up this tool, you click on the little plus at the top, and then you can add fascinating data, amazing visualizations, including the sea surface temperature. And you can show that weekly, monthly, or yearly. And using these data points, basically the students can click on different places that the sanctuaries are found at, and then get some data that they try to predict which years were El Nino and which years were La Nina. And if you're not familiar with La Nina, that's where the water is a little cooler off the coast of South America, and that totally changes the weather and climate. So this phenomena, we start with the story of the South American fishermen that first noticed periods of unusually warm water in the Pacific Basin in the 1600s. They called it El Nino de Navidad, or Little Boy of Christmas, because El Nino events typically peak around December. So the students read through that little scenario, the true story, and then start collecting data. We start them with this data table here from one of the monuments, and they can fill this in. By the way, I should point out that all of the handouts can be either printed and filled out on paper, or they can be filled out electronically. This took us a little time, but we really wanted to make it easy for you to go paperless if you'd like to. So you can distribute this to students through a tool like Google Classroom, and they can fill this out online and send it back into you if you don't want to have to print it. So all these little blue fields you see, those are fillable and they can be saved. You can also add comments if you use Adobe Acrobat, so the students can add even more than these boxes if they need to with comments. So they go through, get their data together, and then again, we ask them to graph it. With this one, we do suggest if you have time, you can go through the lesson plans in order. We try to scaffold them. This one has a little bit less filled out. The students will have to think about what the y-axis should be labeled, what the legend should contain, and then graph that data that can be shared with the class in the explain phase. During the explain phase, we also suggest showing a short video. This is one from Climate Bits, a wonderful series from NOAA. It's just 2 minutes long. The students will get all the terminology. They'll see more amazing visualizations that show how El Nino and La Nina work. And then get the students talking, thinking about this, ask questions. We put a number of them in the lesson, such as, why do ocean temperatures vary so much? Why are some ocean waters warmer or colder than we might expect? And then give them plenty of opportunities to talk to each other about this. We know from lots of research that it's a very social process. And so if the kids have a chance to share with each other, share with the class, share their graphs and maps, they're going to learn a lot more and learn a lot more from each other. Some of the Enrich Extend activities are to use NOAA's Data in the Classroom program. We started from the El Nino module that they had created and just kind of added to it. And you can do the same thing with sea level, coral bleaching, water quality, ocean acidification. These are very powerful learning modules that use these data visualization tools and provide a lot of extra support for you. So check those out. We link from the curriculum. We also suggest that anytime you bring up how the ocean's changing, the climate's changing, give students a chance to think about solutions to these problems. They are things that millions of us around the world are working on, and they should know that there are many reasons for hope, and they may have ideas for how to address them as well. Those can be shared through a medium of their choice to try to get other folks more aware of what's happening and ways that we can solve the problems. One of the tools to help do this is called Climate Resilience in Your Community. It's an activity book that's free from NOAA. You can print it out online, and the students can go through and take all kinds of actions to be more climate resilient. They can even get badges and stuff along the way. A terrific resource that some other folks put together. The second lesson gets into the phenomenon of albedo. And you've probably all experienced this, even if you haven't heard it before. And it's that many surfaces reflect a lot of energy back, such as sea ice, and many substances will absorb a lot of energy, such as open ocean water. And it's basically a ratio of the amount reflected to the amount absorbed. So if you have sea ice, it's reflecting most energy back, so it has an albedo close to 1. It's about 0.9, depending on how white that ice is. And if it's open ocean water, it's about 0.1, depending on how dark that water is. And
Oh, 0.1.
0.1.
Yeah, that's right.
Yes.
Sorry.
I got my fact checker, but I think I'm okay.
Yeah.
So we suggest starting not from sea ice, but start from something the students can feel directly. Just go outside, do this one on a warm sunny day, go out to the blacktop and let them really feel that heat being absorbed by the dark black asphalt. And then bring out some thermometers, give the students a chance to try to compare 2 different locations, maybe the blacktop compared to green grass or a tree, and see which one is warmer and by how much. And it's really very dramatic for them to see that effect of albedo. So this is an example of cause and effect, that cross-cutting concept that you can do throughout these lessons. So here's the sun shining down, and there's just no substitute for going outdoors if you get the chance to do that. And we do have throughout the lesson plans opportunities to integrate outdoor learning in with the content. All of them can be done in the classroom. We know it's not always possible to go out, but if you get a chance, it will really increase the engagement of students and how much they learn and remember. Some of the other ways you can bring in the 3 dimensions of NGSS here, in addition to the ocean and climate literacy content, they're going to design and conduct experiments. The quick ones outside, comparing different places, but then you can also provide some resources students can use, like different colored fabrics, different colored papers, some lamps, if you have some heat lamps around your school building or education center. And then have the students just try to design their own experiment, and they can share those results with each other. You can also bring in cross-cutting concepts like stability and change. If you add that extra energy, how this is going to impact the properties here. It could be fabric, it could be paper, or it could be sea ice and ocean water. So we suggest bringing in this concept of feedback loops, and the students can create a diagram to explain this concept. This is one of the things that's really fueling climate change right now. And so it's a good opportunity to bring it into this lesson, to integrate climate literacy principles like principle 3, that's life on Earth depends on, is shaped by, and affects climate, and principle 7, that climate change will have consequences for the Earth system and human lives. And if you're not familiar with this concept of a feedback loop, one of the classic examples here is that sea ice is melting rapidly, and as it does, you're going from a very high albedo, where most of that energy is being reflected back by the white ice, to most of it being absorbed by the dark water that makes it accelerate much faster after that. And so this is a chance for students to understand why the climate's changing so fast now, and why we should be very motivated to try to slow this down. And then again, any chance you get, give them a chance to think of solutions and act on them. It totally flips the story of being a very concerning thing that many students are talking a lot about. We hear from our friends' kids and nieces and nephews. They're thinking maybe they won't have kids because they're worried about climate change. Well, make sure they know that lots can be done, and these problems are totally solvable. Give them a chance to try to help solve them. Go plant some trees together, or do some things that can absorb extra carbon, provide shade to keep it cooler in your neck of the woods, and things that'll make them feel hopeful. All right, so let's take a moment to pause here and see if there are any questions. I'm going to take a look at Q&A. You can be adding questions at any point throughout the workshop. I don't see any. Tracy and Deanna, have you seen any questions pop up, or does anybody have any right now?
I haven't seen anything pop up yet, but if anybody has any questions that I think of during the presentation, feel free to add them in.
Thanks. Okay. And of course, if you have any more ocean humor, puns with a porpoise, or anything else, you can drop those into Q&A too. We would love to chuckle with you. Oh, let's talk about the links.
So
You want to talk about the
yes,
links?
I'll mention that we do have quite a few links in this presentation, and I know Deanna is dropping those into the Q&A. But we will also be sending you a list of links with the certificate of attendance, so that you have all those links handy in one place as well. So don't get too distracted with writing those down. You'll be able to have those later.
Yep. And so with that, we're just going to take a quick break. We will be within earshot. Deanna or Tracy, if you hear any good or see any questions pop up, feel free to let us know. Otherwise, we're just going to stretch, let our backs kind of work it out a little bit, and we'll be back in 2 minutes. And just, if you have a little time, think about how you can use these lessons. Take that moment to kind of reflect and think about how it'll work in. Maybe jot down some notes so that it'll be fresh when you get back to school or your environmental education center. Thanks, everybody. See you in 2 minutes.
Oh, Laura, I see that you have your hand up, so we're not going to be unmuting anybody. So if you have any questions, please put it in Q&A in the writing part. And thank you for everybody who has been putting their name and where they are in the first post that is on the Q&A sections. I see we have some people from the Olympic Coast. We have people from Santa Cruz. We have people from Virginia Beach. So thank you so much for everybody. And if you want to do a shout out to who you are and where you're coming from, that's always really fun to see. So feel free to put that information in the Q&A. Yeah, some people from Texas.
Okay, hi everyone, welcome back. I'm going to turn it back over to Krista for our next principle.
Thank you. I hope you're all back. So ocean literacy principle 4, the ocean makes Earth habitable. And this beautiful organism is magnified phytoplankton, also known as microalgae. Back to our table of lessons. Again, this is principle 4, and we have 2 lessons under this principle: an ocean of oxygen producers and ocean origins of life. Lesson 4.1, an ocean of oxygen producers. This lesson focuses on how marine photosynthetic organisms contribute oxygen to our atmosphere. What makes these cells green? We first engage students with this phenomenon. Take a moment to observe. What do you think you're looking at here? This graphic is showing seasonal change of chlorophyll concentrations in the ocean. We ask students, what is chlorophyll and why is there chlorophyll in the ocean? And the next couple of slides are from the teacher presentation. Which ecosystems do you think of when you hear about oxygen production? You're not alone if you thought about a lush rainforest. Which of these organisms produce the most oxygen on Earth? Is it all rainforest plants, all grasses, or these little photosynthesizers in the ocean? So at least half of the oxygen production on Earth comes from the ocean, and 20% comes from Prochlorococcus cyanobacteria alone. If you remember that the ocean makes up 71% of Earth's surface, this makes a lot of sense. Our objectives for this lesson are that students will design and conduct an experiment to test if photosynthesis occurs in an aquatic organism. And we suggest that you purchase Elodia for this purpose. We also suggest that students do this lab activity in groups. They're given a list of supplies, including a chemical indicator of carbon dioxide, and are tasked with designing an experiment. They will discover that land plants are not the only organisms that photosynthesize. We ask them to argue from evidence about how photosynthesis by marine organisms could impact atmospheric oxygen levels. We also ask them to discuss how over eons the ocean produced enough oxygen to make Earth habitable. And scientists believe that until 600 million years ago, the atmosphere had less than 5% oxygen compared to 21% today, which is obviously a huge change. We ask students also, where do marine photosynthetic organisms live in the ocean, and why? And as you know, sunlight is one of the 3 ingredients for photosynthesis, and sunlight does not travel very far in the ocean. So photosynthesizers stay in that upper 200 meters called the photic zone. The second part of this lesson is that students will research and present about a marine organism that photosynthesizes and consider the importance of those organisms as contributors to atmospheric oxygen. We have a list of the possible organisms they might research. And one Enrich Extend option is that students research the importance of algae or seaweed in indigenous cultures. And in Hawaii, seaweed is called limu. If students ask you, why should we study this?
'Cause you oughta. And this is from our friend Sandy Yellenberg. She was visiting last week and she gave us wonderful feedback on the presentation that improved it for you all. And she had some great puns along the way. So thanks, Sandy. Oh, and if you didn't know, these sea otters are really critical for kelp forests too, because it turns out they eat all these sea urchins that are eating the holdfasts of the kelp forest. And so the otters keep that ecosystem healthy. Thank you, otters.
And if that wasn't enough, here's another one for you. Why don't algae go out on dates?
Their relationship is strictly platonic.
Very good. But seriously, almost all life in the ocean depends on these tiny photosynthetic organisms known as phytoplankton. So thank you, phytoplankton. The second lesson under Principle 4 is Ocean Origins of Life. And oops, I was going to mention that beautiful organism is a comb jelly, also called a ctenophore, which is thought to be one of the most ancient animals. And in this lesson, students explore the evolution of marine organisms and discover that life evolved in the ocean. Questions we engage students with are, what do you think was the first animal? Where do you think it lived? What are fossils and how are they important for science? In small groups, students use cards with brief descriptions of extinct organisms and attempt to match with the correct image of that organism. Then they try to order these from simplest to most complex based on anatomical structures and body systems. They hypothesize which organisms evolved first. Then they match a living marine species with its extinct relative, noting similar traits. We ask them, where do these modern organisms live? And students conclude that it is the ocean. And here are a few of those National Marine Sanctuary sites where these organisms reside. The culminating project for this particular lesson is that students will create a Sanctuary Survivors poster project. They'll choose a modern organism that lives in a national marine sanctuary and use the sanctuary's website to research it. Then they'll create a poster for that sanctuary that focuses on the organism and an extinct relative. And we love these sanctuary posters so much and think they're a great inspiration for students to use as they develop their projects.
Yeah, you can get them all at that website there, sanctuaries.noaa.gov/posters. You can print them out, have them around your classroom. Gotta love free art.
And this lesson segues really well with the next principle, which focuses on the diversity of living marine species.
All right, so that is Ocean Literacy Principle 5, and it's that the ocean supports a great diversity of life and ecosystems. And this is an amazing image taken from American Samoa. We're going to bring in our wonderful colleague Belle here in a moment to share more about that remarkable place. But first, we're going to just give you a quick overview of the principle. So we start with modeling coral reef ecosystems. Then we get into tidal tails, where we look at tide pools, or what we call intertidal zones and subtidal zones. And then we go out even further and look at deep sea coral communities. So this virtual dive is pretty amazing. I'm just going to share my screen so you can see this virtual dive that you can pull up from the web, and hopefully this will work here, and you can see hopefully Big Mama. And on this virtual tool, you can maximize this so it'll fill your screen. Hopefully you have a data projector. You can zoom in and out of this. You can rotate, maybe have a student come up and really get a sense to explore this remarkable coral formation. They estimate that this is over 500 years old. And I'm going to not delay here, and I'm going to turn it over to Belle, but just wanted you to see this tool you have access to. So Belle, are you ready to take it away?
Yeah, thanks, Rick. Let me share my...
And while she does that, let me do a better introduction and say that Isabel Bell Halatui Tuya is an educator from National Marine Sanctuary of American Samoa, and an Indigenous person who's also bilingual with the Samoan language. And we're just so thrilled that she could join us tonight.
Can you guys see my screen?
Looks great.
Yes.
Okay. Yeah, I forget I can't see my screen.
Right.
Um,
Weird.
Yeah, Faftai Lava, Rick. Greetings, aloha, maluelele, pulavinaka, hafade, kiorana, ali, and talofa from American Samoa. My name is Isabel Halatuituia. I am the education coordinator and IT specialist for National Marine Sanctuary of American Samoa. It's an honor and a privilege for me to share my culture and Samoans' connection or relationship to the ocean. American Samoa is the easternmost part of the Samoan archipelago, a 301-mile-long volcanic island chain in the Polynesian South Pacific Ocean region. American Samoa is located roughly halfway between Hawaii and New Zealand. Fasamoa refers to traditional Samoan lifestyle or way of life. It is the foundation of Polynesia's oldest culture, which dates back some 3,000 years. The ocean is the source of our Samoan life. It has sustained our people from generations and is still critical to our economy, culture, and livelihood. One of my favorite traditional community practices is the harvesting of akule or big eye scad. Akule season appears in large schools in April, May, and October. These are often collected through communal efforts called lauloa. A traditional launiu or coconut frond is used to encircle and catch the akule. Thousands of akule are catched this way, distributed equally to all the village families and given to other villages as gifts. The villages of Whangasa and Leone harvested akule this year. The palolo is an edible polychaete worm, and its mating season follows the lunar cycle, usually on the seventh night after October full moon. To the untrained eye, they appear to be worms, but Samoans call these sea creatures palolo, sometimes referred as the Samoan caviar. When Samoans go to Kapalolo or harvest these, they often bring flashlights, fishing nets, and as you can see in the picture, moso'oi lei or necklace. It's a fragrant flower which is said to attract the palolo worms. They are found in shallow coral reefs and are often brown and bluish green in color. Because the palolo melts in the sunlight, the hunting must also be done in the dark, usually in the early hours of the morning. American Samoa has a long, continuous history of maritime activities and connection to the ocean. From the initial voyaging discovery by Pacific navigators thousands of years ago to a long-range fishing fleets and modern Fautasi racing craft of today. The Fautasi longboat derives from the blending of Samoan watercraft and Western whaleboat tradition, producing the paddle Taumalua racing and war canoe back in 1849. Today, Fautasi racing is the main event of the American Samoa Flag Day celebration in April 17th. The entire village supports their own team's training, which can last up to a month or more before the race. Fautasi history, ranging from warfare to racing, is part of Samoa's larger maritime cultural landscape of watercraft. So, our ocean is a wonderful tour destination to explore above and below, and we welcome all to visit our islands and National Marine Sanctuary of American Samoa. So, circling back to our Samoa and our livelihood, the ocean is part of our identity, and we hope to preserve our traditional knowledge and practices. And in doing so, we need to understand and value the importance of our ocean by protecting and preserving precious underwater resources, along with our unique maritime cultural heritage. There are over 150 species of coral make up the centerpiece of marine life in National Marine Sanctuary of American Samoa. One of the most popular coral is Big Mama. So, like the 3D image that you guys were able to see previewed, Big Mama is a massive Porites coral colony that lives in National Marine Sanctuary of American Samoa on the west side of Ta'u in an area called the Valley of the Giants. Big Mama is the largest of several massive Porites in that area and is one of the largest known coral in American Samoa and possibly in the world. There are more than 1,400 species of other invertebrates, algae, several seagrasses, humpback whales, over a dozens of other species of whales and dolphins, hundreds of fish species, over 30 seabird species, and hawksbill and greasy turtle are all protected by the sanctuary. And lastly, less than 5% of our ocean has been explored. Exploring the deep improves knowledge of our ocean. The shallow and deep sea will help us sustainably manage and take care of our ocean resources. Now we need to pass these skills and stories to protect, learn, and value the importance of our ocean and our way of life. And the perfect way is to have these lessons shared, implemented into the classroom today. So I'm very grateful for the team here tonight for inviting me to be part of this. Um, and it's an honor to have American Samoa as an example for the coral reef ecosystem lesson. Before I do pass the time over, I wanted to uh, say a quick joke. Last time it wasn't funny. Hopefully it'll be funny with a little bit of a slide. So after World War I, the U.S. was granted several island territories in the Pacific Ocean. Hawaii being one of them, they ending up liking it so much that they wanted Samoa.
You're awesome, Belle. Thank you.
If you want to know more about National Marine Sanctuary of American Samoa, you can visit our website, our Facebook page as well. But if you want to talk stories and share opportunities for our teachers, our students, or even our people in general, our community, you can email me as well. So Faftai for your time, sending everyone love here from American Samoa. God bless.
Thank you,
Thank you,
Belle.
Belle.
Love right back at you. You're such a wonderful educator. We couldn't have done this lesson without Belle and team. We did focus on the species found in American Samoa, most of which are found in coral reefs around the world. And so we hope that you enjoy learning more about these remarkable ecosystems. And so some of the resources you have, I'm just looking at our time here, and I'm going to go very quickly, but you'll see this. It has a number of species the students can choose to research. Then you can model these ecosystems in a web of life where they use yarn to get connected in the ecosystem. You'll see that in the lesson plans. They can also model this with a concept map. And there's an example here that you can share with students where they use different colored arrows to show different flows of energy around the ecosystem, and they can model this. I mentioned Tidal Tales 5.2. This is where the students do simulated monitoring of tide pools, also known as intertidal zones. We ask them to look at differences between healthier and less healthy intertidal zones. Ask them to think about how they could study subtidal habitats. These are offshore, and so we really need technology like ROVs to do that. The third lesson goes deeper out and actually has videos, real video transects. A transect is a way to monitor over a certain period or a certain distance, and this uses videos where the students can learn different species using these ID guides and the PowerPoint presentation that's included, and then they can fill out their data sheet with the different species they find to do these transects just like scientists do. With Principle 6, they go more into the human connection. So we're really happy that Belle could join tonight because she was able to highlight many of those human connections to the ocean. This principle, our lessons go into those deeper with the mystery of the disappearing shells and also clues from albatross, determining ocean health. And for this first lesson, we don't want you to tell them what it is, just show them a couple pictures here and think about what are these organisms and how might they be different. They're pteropods. If you haven't seen them before, these beautiful creatures, sea butterflies. And these are really good indicators of ocean acidification. Just between us, we say don't tell the kids right away what they're looking at, but these little pinhead-sized things are very affected by acid ocean water. And you can see with these photos, they can see over time how they'd be affected in acidic water. And then there's an experiment where the students use acetic acid, vinegar, just regular white vinegar in a solution to see the effects. They can see the bubbling of different bivalve shells right away. So if you have clams or oysters, save those shells and you can use them in your next lab experiment. This is the mystery of the disappearing shells. And then they can argue from evidence how acidity from greenhouse gases affects marine biology and propose solutions, again, to limit these effects. And then we also tie in the cultural importance of bivalves to Indigenous peoples and other communities around the world. With the second lesson, we get into albatross and how they're great indicators of ocean health as well. We've got the marine monuments, Papahana Makuakea in the northwest Hawaiian Islands. And we talk about how one of them is a seabird sanctuary, Kure Atoll, or Holaniku, and how the birds will migrate thousands of miles to get to that sanctuary from the west coast and back. And they're feeding all along the way. And the things that they're feeding on aren't always great. So when they feed their chicks, everything that they've been eating, the chicks also eat. And then the chicks, as they're maturing, will produce these boluses, kind of like an owl pellet, if you've seen those before. And from this phenomena of these bolus that come up, we can learn a lot about ocean health or unhealth in this case, because they're all full of plastic and other things. The kids can look at a dissected bolus and analyze the data using a data sheet to keep track of it. There's also an interactive tool that they can use that's online. And if you click on the things here, it'll show you a bigger picture. They can use the ruler tool to measure them, and then also to classify these things, and it'll keep track of the data. Then they can analyze that doing graphing and percentages and thinking about how much of this is something like squid beaks compared to plastic and foam and fishing line and all the other terrible things that these birds are ingesting. And we found that this lesson is really impactful for the students and really motivates them to take action to address this crisis of plastic in the ocean. It's part of the Winged Ambassador series. I'm just going to cruise through this as another resource there, highlighting a scientist. You can get a whole curriculum focused on albatross at downloadwingedambassadors.org. That's one of the links that Deanna will be sending out to you later. With the last principle, we get into ocean mysteries and how life on Earth, or the ocean is largely unexplored. I'm going to turn it over to Krista for continuing the speed tour.
All right, thanks. So the last 3 lessons in this curriculum are more student-centered with choices of topics to study. And research shows that choice helps keep students motivated. In Surfacing Ocean Mysteries, students choose an ocean phenomenon to research and prepare a presentation or poster. We ask them to argue from evidence why their topic is significant and how it relates to the statement, "The ocean is largely unexplored." We also ask them to explain the benefits of ocean exploration. And on the right, you can see is a student handout there with topic choices. Some of them are biological, so organisms they could research. Some are geologic with hydrothermal vents or seamounts they might explore. And then shipwrecks are also an option here. Should we show the video?
Let's do the video at the end if we have time.
Okay. So here we have the student handout shown. And so questions here guide students through the research process of investigating their phenomenon and will help them prepare for their poster or presentation. And on the right here, we have a rubric that is included with the lesson. There is a column for students to score themselves when they're ready to present or share their work product. And then there's also a column for the teacher score for you to fill out. Back over to Rick.
All right, and the second lesson here gets into the various explorers that are involved in unlocking these mysteries in the ocean. And these are different careers the students might consider pursuing, such as marine biologists, geologists, archaeologists, other types of scientists, as well as many other types of professionals like science communicators, filmmakers, and technology experts. And like with some of the other activities, the students can choose folks that they're interested in, or they might know of somebody else they'd like to learn more about. After they've selected a number of folks, they can rank them in order. Again, you can use little comments in Adobe Acrobat to add these if you want to do this electronically. And then when you go around and ask the students who they want to choose, hopefully they have one of their top choices that they're able to learn more about. And they're researching the methods scientists use and challenges of exploring the ocean, as well as different ways the science discoveries are shared. And that's another one of the important cross-cutting concepts is, it's not just learning the phenomenon. As scientists, we need to be able to share that effectively with others. With the last lesson in the curriculum, we kind of bring it all together in this culminating experience where the students have kind of learned about different ocean mysteries. They've learned about professionals who are exploring them. They've learned about a variety of different technologies that are used, and then they're ready to plan their expedition. And so this can start with a question they want to answer about an ocean phenomenon. Like Krista said, we did have a video we were going to show. We might show it in a moment here, but there's lots of videos linked throughout the curriculum that you can share with students so they can see some of these very cool phenomena that they might want to learn more about. And then they need to think about what experts might they hire to help them. These expeditions that are going on all over the world, ships like the Okeanos Explorer, NOAA's research vessel, as well as Nautilus Live from Ocean Exploration Trust and other partners, they are learning new things every time they dive, but they can't do it on their own. They need a lot of people to make it happen. They need a lot of special equipment and technology. And so the students need to think about this. So there's a budgeting component. They only have a certain amount of money to spend, and then they need to decide, are they going to need a chief exploration officer, a navigator, who could they, maybe not bring with them, and who do they really need to have on board? Same with the technologies. If they want to study some of these remarkable deep sea creatures, how are they going to get down to them? How are they going to be able to either photograph them or collect specimens and get them back to the surface? All these things that real ocean explorers need to consider. And then they can write their budget narrative that tries to justify why they need these things, how much they're going to cost, and why this research is important to try to get this funded. You can even do it, we put in as an enrich extend activity that the students can make their case to the rest of the class, and then they could vote on which ones they think are most important to pursue. Anytime the students are doing a original research project like this, it's really just so important if you have time to be able to let them not only share it with your own class, but also invite others, invite the principal, invite other community members. We need to engage the whole community in understanding about the ocean, helping them understand the ocean literacy principles, and students are the ones that they're going to listen to the most in our experience. I'm going to do a quick shout out to the Ocean Foundation and this Youth Action Toolkit. You can find this online. Deanna will share the link, ways the students can engage with helping the ocean health. Really try to stress every chance you get about the connections, those personal connections the students might have, if they're cultural connections, different foods that are important to their cultures. Maybe they can bring those in and share them with the class. highlight the ocean production, the oxygen production, the different weather impacts, our watersheds, the plastic and trash that's getting into the streams and back down to the ocean, different ways that the ocean keeps us healthy physically and spiritually and mentally through recreation and other connections with that special place, and all those amazing organisms that keep us inspired. So thank you so much for joining us all tonight. If you could please take a couple moments. I rushed so that you would have time and you could all do this before you leave. Please, please, please do this evaluation. Deanna will drop the link into chat, and you can also just type in that tiny URL there. And if you have any other questions at all, please type them into Q&A. I'm sorry that we weren't able to turn on the cameras. We would have loved to have met you all tonight, but please get in touch with us. If you have more ocean humor, that's always appreciated. You can put that in Q&A as well, or email us. And as an added incentive for completing that evaluation right now, you will get a link to this brand new video game. We just this morning released completed chapters 1 through 3 with a new professional narrator, an amazing BIPOC narrator named Crystal Cohen, who really brought this game to life. It teaches all about the ocean, the water cycle, how the water cycle is changing because of climate change with extreme weather, and ways that we can take action for a sustainable future. And so it's called The Astounding Adventures of Maddie the Water Molecule, and it's totally free, supported by the CO2 Foundation. Again, in case we didn't stress this enough, thank you to our sponsors, the National Geographic Society, that funded the workshop tonight and the whole curriculum. So we couldn't have done it without them, and all the other partners, the National Marine Sanctuary Foundation, NOAA, and so many other educators like Bell and people around the world that made this all possible. So thank you, everyone. The work you do is the most important on Earth, and we hope you can all live with puns, porpoise, and hope. Thanks a lot. And there's all our contact info, so you can keep in touch. What did I forget?
We are ready to answer questions.
Yes. Are there questions?
I saw that Sandra put up her hand, so I assume that Sandra is now writing in a question.
Okay.
Great.
Thanks, Sandra. We will watch for that. And in the meantime, everyone, please fill out the evaluation. There's the link again. Nice short, tiny URL for you.
And maybe we can show that video
Yeah,
too.
I think we actually have a minute. Let's just go back out for the folks who are interested. There are some really amazing videos online, and we wanted to just share a quick one here. Let's just share. Let me go back to the. Here we go, everyone. Oop, I forgot to share sound. One sec. Stop sharing. Try that one more time. Oh, I got to share sound again.
Hey.
Wait. There's the button.
Okay.
Got it.
Got it.
All right. So now we got this. That. I'm not sure the sound is working.
Bit of water.
Oh, Jumbo.
Oh,
Jumbo. And those small colonies were found to be somewhere between 100 to 200 years old.
What are you?
yeah, this is really cool.
It's like a bloated squid with tiny.
Is it just?
Look!
Oh my God! Look at that!
Wow.
Like the flower.
Depending on the starboard partition side of the forward line box. Don't worry.
Dropping a target here for sure.
Drop like.
Whoa.
All right, so our students really grew up as digital natives with lots of videos, and so being able to use those going down, miles below the surface to share phenomena like that with students can be very impactful. And hopefully inspire them to start doing their own research projects.
So we have received a question from Sandra, which says, do you have any recommendations for the Gulf Coast for comparison lessons?
The Gulf Coast for comparison lessons.
Ooh.
Yeah. Let's think about this. When you say comparison.
Yeah, so there are some lessons existing that are located in Flower Garden Banks National Marine Sanctuary. We didn't include that location specifically in our curriculum, but I know there are some lessons out there that do talk about Flower Garden Banks, and I just can't remember off the top of my head which ones they are, but we can look for those and send those to you, Sandra.
Yeah, if you wouldn't mind putting your email in chat or in Q&A or emailing us. I'll put my email here if that's easy. We will get back to you. Thanks for asking the question.
I'll try and find those. I know they exist.
Yeah, we are totally happy to help. This is a labor of love for us. And so really don't hesitate if you think of anything at all. If you'd like editable versions of things, if you'd like the Spanish translations before they're up online, hopefully in the next week or so, let us know about any of that too.
Thank you for that great question.
Yeah.
Just so excited that we have so many people from the Pacific tuning in.
Yes.
Thank you everybody who was able to attend.
Yeah, that was just so neat to see. And yeah, how far away folks are traveling or are able to zoom in from showed us that it was a good idea to do a little later workshop here to make it easier for folks far away to join. Any other questions or thoughts? I keep trying to share my screen because it's not actually sharing the whole thing. I'm going to try one more time and see if it'll let me share the whole thing.
Somebody said they were having issues accessing the tiny URL evaluation code. I just put the long code in, or the long link, and so please try to click that. And if you're having issues, please let me know.
Oh, I gave the punchline away. All right, so before we leave, we had one last little joke here, and unfortunately, Teams is not working out very well. But this was also from Victoria. ¿Cuál es el último animal del mar? That's the last animal in the ocean. And you can see the punchline there. It's el delfín. Delfín is Spanish for dolphin, and fin is also for the end. So that's the end of our workshop. Thank you all for joining us, and thanks to Victoria for the fun puns and for everything you all do out there. Let's all save the ocean together and enjoy it, and make sure that it's the wonderful ocean that we all enjoy today for future generations.
Thank you everyone for joining us.
Belle, I saw you raised your hand.
No, it's right next to, it was right next to the react. So I was trying to hit the react, but instead I hit the raise.
Okay, understood. Okay, I'm going to end the meeting for everybody. So thank you, everybody, and I hope everybody has a lovely day.
Thank you.
Great to see you all. Good rest of the week and happy holidays.
Happy holidays.
Bye.
Bye.